In this lesson, we're going to be solving systems by substitution. So if you remember last time, we were solving systems by graphing, and the answer or the solution was the point of intersection. So we're still going to be finding a point of intersection. We just won't be given lines. We're going to solve that algebraically. The key to this is to get one variable by itself and then plug it into the other equation. So you're going to solve for one variable and then substitute into the other one. So the first example is negative 3x plus y equals negative 11 and x minus y equals 21. So I have two equations, two unknowns. This is my system. So you may see it with the curly brackets around it. Now the variable that I know to solve for is I always pick the positive variable with no coefficient. So in this case, that would be this x or this y. I can solve for any variable. Those are just going to be the easiest. So I'm going to pick the first equation, and I'm going to solve for y. So to solve for y, I need to move the x over. So I'm going to add 3x to both sides. And then I'll get y equals. So that's the same thing as the first equation. So that's the first equation that is solved for y. So now I'm going to take that, because that is y equals, I'm going to plug it in to the second equation for y. So I solve an equation for a variable and then I take it and plug it into the other equation. Don't plug it back into itself, you'll get the wrong answer. So I'm going to take my second equation, x minus y, and I'm going to plug in where there was a y, I'm going to put my other equation. Now, since I've plugged in the other one, or the first equation, into the second equation, I now have one variable. I have just x's. So now it's just a matter of solving. So I need to distribute. Combine up like terms. So now I'm just working on solving for x. Divide by negative 2 and get x equals negative 5. Now, up until now, we've stopped there. However, I have two unknowns, so I have to take x, back substitute it into one of the equations. Now, I can substitute it into either of the original equations or this one I solved for. It's going to give you the same y, but it's easier if you substitute it into the one you solved for. So I'm going to take my x and substitute it right there. And this is called back substitution. So I've got y equals 3 times x, but I found x to be negative 5. So I can either put this in my calculator, do it in my head, however you want to. So my solution is x equals negative 5, y equals negative 26. Now I write this the same way that I wrote them before, as a point. So I've got the point negative 5, negative 26. Now if I wanted to check it, I would make sure when I plugged in negative 5 and negative 26 to both equations it made it true. So in the first one, I want to make sure that when I plug in x equals -5 and y equals -26, I get the same answers. And I want to know, is that true? When I plug that into my calculator, I get -11 equals -11. So that one's good. Now I have to check the second equation. So I'm going to do x minus y equals 21. Check that. So x is -5 minus -26 equals 21. And I get 21 equals 21. So I know that that answer is correct. So this last example has some decimals, but it's still going to be the same thing. Notice none of these variables have a coefficient of 1. So I just have to pick one that's going to make it somewhat easiest. If none of them have a coefficient of 1, then pick a positive one, because then you don't have to worry about a negative. So that means I could either pick 3x to solve for that x, or 0.3y to solve for that y. I'm going to solve the bottom one for x. So I'm solving So I'm going to solve for x, so I need to move this thing over. Now, order doesn't really matter for substitution. You don't have to put the variables first, you don't have to put them second, just as long as you keep them consistent with their signs. So I'm going to divide everything by 3. So there's my second equation solved for x. So now that I have that, I'm going to take that equation and plug it into the other one for x, because it says x equals. I'm going to plug it into the first equation where there was an x. Now the reason I draw this line from the second one is that reminds me that I solved the second equation. So that way I know when I find this answer which equation to plug it into. If you don't draw these arrows, it may get confusing. Then you may end up plugging the equation into itself, and you won't get the right answer. So make sure you keep straight with what you're doing. The key to this is to be very organized with your work. So now I'm going to take this equation and plug it into the first. Now that the first equation says -1.5x, but x in my case is 4.8 plus 0.2y. And then I'm going to finish filling it out. Now I need to distribute. Because you have a calculator, decimals shouldn't be an issue. Just multiply them like normal. I get -7.2. Distribute again. Carry everything down. Now, because substitution, the way substitution works is I will have one variable. So that's why I can do all of this solving in this step right here because I only have one variable. I just have y's now. So now I'm going to combine my like terms. You notice when I combine those, I've got negative 0.3 and positive 0.3y. Those are actually going to cancel out and give me 0. So I can cross through those because those cancel, which leaves me with just equals 7.5. Now, anytime your variables go away, it's going to be one of your special cases. So think back to the last chapter. We had two special cases. No solution, which were parallel lines, and infinitely many solutions, which were lines that sit right on top of each other. So now in this case, I have two numbers. And if it gives you a true statement, that's infinitely many solutions because it's always true. If it gives you a false statement, like in this case, that is no solution. So if a true statement and if you have a false statement, and that only happens when your variables go away. So if your variables cancel, that's when you have infinitely many or no solutions. If not, like example 1, it's just some point, the point xy.